Okay, we're back here. Let's go ahead and start part two. We're on the back of these notes, and we're going to do two more examples. So let's look at example 3. Looks like we've got these two triangles on the left and on the right. Given angle M is congruent to angle H, and then segment MT is congruent to segment TH, we want to prove the triangles are congruent. That's our goal. So we're going to start here. We're going to finish here. Now, to prove the triangles are congruent, that means we're going to finish with side, 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 angle, angle, or angle, angle, side. All right, so let's go ahead to the columns. Statement number 1, let's write down what's given. Angle M is congruent to angle H, and segment MT is congruent to segment TH. The reason we can say that is given. Now let's go to the picture and label it. So angle M is congruent to angle H. Segment MT is congruent to segment TH. All right, so we've got two things. We need one more. Now when you look at this, I'll tell you a common mistake people make. They say AT is congruent to TG. We don't know that. We cannot say that. They tell us that MT is congruent to TH, so that means T is the midpoint of MH, but it doesn't make it the midpoint of AG. Okay? But we can't use that, but we have something else we can do. Notice that when these two segments cross, they create these two angles in the middle. Those are vertical angles. They have to always be congruent. So statement 2 is we'll say that angle, this is MTA. You have to use 3 letters here. You cannot just say angle T. So angle MTA is congruent. So there's angle MTA. I'm going to use 2 arcs. Is congruent to angle, this one, HTG. Angle HTG. And the reason we'll say, reason 2, vertical angles, we'll use a little symbol, angle apostrophe S, vertical angles congruent. That's always true. Now if I look in my proof here, I see 1, 2, 3 congruences. And in my picture, we got 1, 2, 3 congruences. 1, 2, 3. All right, so that tells me we might have enough information. Let's look at what we got. If I look at one of the triangles, we've got 2 angles. Okay, we've got an angle, there's an angle, they're congruent, and there's a side that's congruent, and the side is between the 2 angles. It is included. So we can say that's enough information. Triangle MAT is congruent to triangle HGT, and the reason? Angle, side, angle, ASA. That's it. That's all we're doing. Some of the proofs, okay, 3 steps, that's pretty fast. Sometimes it might be 5 or 6. You may have more than one thing that you have to find. No problem. Everything is step by step. And you have to give a reason. You have to justify. All right, we'll do one more here. Put the statements and the reasons into the correct order. So this time, they give us all the statements, they give us all the reasons, but they're not in order. So we've got to figure out, okay, how are we going to put this into our proof? How are we going to put that into the columns? So, well, let's see here. What do they give us? QR is congruent to TS. QR is parallel. That symbol means parallel to TS. Prove that angle R is congruent to angle T. Well, we know where we're going to start. We're going to say that, let's put our given. So segment QR is congruent to segment TS, and segment QR is parallel to segment TS. One thing that you'll notice about this, so that's given. When you look at the reasons, there's actually 2 given statements. So I think what they were doing in this proof in the book was that they were going to write these separately. I'm just going to write them at the same time. Okay, so we'll kind of check them off as we go here. QR is congruent to TS. Check. We used it. QR is parallel to TS. Check. We used it. And then we used both of the givens. Now let's go to the picture here and label this. QR is the top segment. TS is the bottom. So they're both congruent. So we'll put the tally marks. They're both parallel. So we'll put these little triangles and we'll shade them in. That means parallel. All right, now in this proof, there's actually a couple ways you can go with your next step. We only have, now these are two things that we've marked, but that's only one congruence. We need two sets of congruence. So what do we see? Well, here, let's do this. Let's use the parallel lines. When you have parallel lines, look for the Z. And what we have here is a backward Z. That means that those two angles have to be congruent. Now let's see, those two angles were RQS and QST. Now let's see, is that one of our choices? Here we go. Angle RQS is congruent to angle TSQ. So let's write that down. There's our step 2. Angle RQS is congruent to angle TSQ. Now, why? Why can we say that? Well, parallel lines create the Z, but you can't put Z. That's not the official name for this. The official name is, if the lines are parallel, alternate interior angles are congruent. Okay, so there's actually a name for this, a little abbreviation. We call this AIP, alternate interior angle postulate. If the lines are parallel, the alternate interior angles have to be congruent when the lines are parallel. So we'll just say AIP, so we don't have to write everything down for that. Let's go ahead and check that off. And let's also take the picture here and let's label that. All right, so we got that. Those are congruent. Now let's see here. One thing about a proof is you can kind of work backwards even as you work forwards. We're trying to show that angle R is congruent to angle T. So that's got to be last. So if I find that statement, that's last. Now those are parts. Those are corresponding angles. Which means that before you can say the corresponding angles are congruent, you have to say that the triangles are congruent. So that's probably the next to last step. But before you can say the triangles are congruent, we have to have enough information to say that. Right now we've got one set of sides, one set of angles congruent. We've got to have 3 sets. You see how the two triangles overlap? Right here at QS, where they cross. QS is congruent to QS. There's your statement. Segment QS is congruent to itself. Why are we allowed to say that? Reflexive. That's the reflexive property. All right, so we'll check these off here. We're almost done. I'm going to mark that in the picture. I'll put an X there for the common side. Now if you look at your triangle, let's look at the one on top here. I see 3 things marked for congruence. We have 2 sides, a side, and a side, and then an angle, and the angle is included. It's between them. SAS. So what we can say, the triangles are congruent. Look at your possible statements. There it is right there at the top. Triangle QRS. I'll write it in blue. Triangle QRS is congruent to triangle STQ. Why can we say that? SAS, side angle side. And if the triangles are congruent, then that means, therefore, angle R is congruent to angle T. Why can we say that? Because if the triangles are congruent, then the corresponding parts are congruent, and we call that CPCTC. CPCTC. And that is the end of the notes. So go ahead and show these to your teacher, and I'll CPCD see you later.